Welcome to Penrose Learning, where we make understanding easy.
You start by preparing your data and environment. This is the first actionable step. You must collect varied, high-quality text and normalize it to UTF-8, removing duplicates and noise. Once done, create a Python virtual environment and install PyTorch with CUDA that matches your GPU. Make sure you pick a tokenizer, BPE or Unigram, define a vocabulary size like 50K, and implement streaming datasets so you can feed batches without loading everything into RAM. Begin training scaffolding immediately after this setup. Next, construct the model and training loop. This is where complexity lies. You implement transformer blocks, attention, layer normalization, and feed-forward layers, scaling depth and width to target size. Then integrate mixed precision training AMP and gradient accumulation so you can simulate large batches on limited GPUs. Use AtomW with decoupled weight decay and a cosine or linear warm-up scheduler for stability. Once coded, add checkpointing and a sharded distributed strategy like FSDP or ZRRO to handle memory and parallelize across nodes. Finish by validating, exporting, and hardening your model so you can use it in production. You should run validation runs to track perplexity and sample generations, then export the tokenizer and model artifacts. Once converged, apply quantization or pruning for inference and export optimized formats like ONCs or TorchScript, followed by latency benchmarks. If something goes wrong, restore the most recent checkpoint, reduce the learning rate, inspect gradient norms for exploding or vanishing gradients, and confirm your data sharding is balanced. This single troubleshooting tip often fixes stalls.
Thanks for watching. If this was helpful, leave a like and consider subscribing. See you next time.